Good morning, everyone. Welcome to Burr Tools' fourth installment of the Oak webinar series. We're excited to have Eric Lund, Controls and Software Engineering Manager at Burr Tool, here with us today. My name is Tim Dute. I'm the Vice President of Sales and Marketing at Burr Tool. I'll be moderating today's event. I'd like to cover a couple housekeeping items just before we get started. For those that are logged in online, you have the ability to submit written questions to Eric. You can type up the questions in the question box, which is located in the lower section of the screen, throughout Eric's presentation. We'll do our best to have Eric cover as many questions as time permits. You will not need to wait until the end of the presentation to submit questions. Any questions submitted but not addressed during the webinar, Eric will respond to via email. Eric's formal white paper and recording of today's webinar will be available in the near future. An email with a connecting link will arrive to your inboxes from marketing@burroak.com. Now, with that housekeeping behind us, now I'd like to introduce Eric. Eric Lund is the Controls and Software Engineering Manager at Burr Tool, and has been with the company for over 21 years. He graduated from Brigham Young University with a Bachelor and Master of Science in Mechanical Engineering, and regularly volunteers with church youth programs and with the Boy Scouts of America. Now, Eric, we'll turn the time over to you.
Thanks, Tim. Today I'd like to cover a few topics with you that are common for your machines to help you. And to date, with the first topic that we'd like to talk about, well, we'll talk about software updates, memory resets, backing up part data to computers, some PLC diagnostics, and then also a little bit about some circuits on our schematics. So starting off with PLC and HMI software updates, to date, customers typically have to wait for us to ship you the micro memory cards and SD cards for program updates. There is an exception to this with our small return vendors and the ESLs. On these, we have to mail the actual operator panel because those operator interfaces do not support SD cards. So I'm going to briefly review the software update procedure. I'll go quickly because you'll have a written copy of the complete procedure. However, I will like to highlight a couple of points that we typically get questions about, and that is, how do you keep your part and machine data for an updated program, and then how do you reset the PLC using the run and reset switch. Now, it's important to remember that you never want to remove or insert a micro memory card from a PLC or an SD card from a HMI when the power is on. You do risk losing or corrupting the contents of that memory card. So let's start with the HMI update. As I just said, you want to turn off the power to the HMI. It's easiest to use the machine's main disconnect, and then remove the old SD card, and then insert your new SD card, and then turn the power back on to the HMI. Now, as the HMI powers up, watch for the loader window to appear. It appears about 30 seconds after the screen is powered up. And when it does, you'll need to immediately touch the control panel button. The Windows CE control panel should then appear. Now, if you miss it, you'll just need to start over again with the power cycle. Then you'll double tap on the backup restore icon, and the backup restore window will appear. And then you touch the restore button, and then follow the prompts that appear during the loading process. And this can take about 5 minutes to complete. However, when it's done, the program is now updated in your HMI. So let's talk about data a little bit. When Burr Tool sends you an update, we will not be able to send you a copy of your current part data. So in order for you to restore your part data that you've developed on your machine since receiving it, you'll need to take a few more steps. Your part data is on your original SD card, so you just need to replace the new SD card with the old one. So to do this, remember, turn off the power to HMI, remove the new SD card and insert your old original SD card, and then turn the power back onto your touchscreen. The new program that you had just loaded will start up and then read the part data from the old card. Now, as far as backing up the HMI program, once you have updated the program to the PLC and the HMI, and you are comfortable that the machine is functioning correctly, you should really back up the HMI program to the old SD card. So why would you want to do this? Well, if something happens to your HMI, like the screen cracks or some other damage occurs to it, you'll be able to replace that touchscreen with the new one and still operate your machine. Another reason is because Burr Oak Tool typically charges you for unreturned SD cards, and you'll want to return those for credit. So you can put the new HMI program on your old SD card to have both the new program and your developed part data on a single SD card. So to do this, again, we'll start off with turning the power off to your HMI, then turn it back on again. And this will give CE a chance to load. And you'll once again wait for the loader window and then touch the control panel button. And then your control panel will appear. Again, you'll tap on the backup restore icon, which will bring up the backup restore window. And then this time you'll touch the backup button. And then again, follow the prompts that appear during the backup process. And this likewise could take about 5 minutes to complete. However, once it's done, the new program that you receive from us is backed up to your old SD card, and you have your part data there also. So let's turn now to backing up or updating your PLC. Again, turn off the power to the PLC, and again, you can use the main disconnect on your machine. Remove the old micro memory card, and you can use the little button marked push to release the memory card. And then insert your new micro memory card, and then turn on the power to the PLC. You'll then just wait for the PLC to start up. It does this and displays a yellow stop LED, which will flash during the entire startup process, which takes approximately 20 seconds. And when the process is complete, the stop LED will stay on. To bring it into run mode, push and hold the key switch in the mem-res position until the stop LED flashes a couple of times. And this takes about 3 seconds. Release the key switch and then push it back into the run position. The run LED will blink for a very short period of time, and then it stays on, and your PLC will be running with the new program. Another thing that we'd like to bring up is browser-based controller update. And we've had some success using Internet Explorer to update the program in our SD benders. The SD bender uses a Simotion, or the Siemens Simotion D425 controller instead of a PLC. This has the capability to allow us to email you a program update, and you can then use Internet Explorer on a computer to update the program in your controller. So now you don't have to wait for us to mail you a memory card and, for the program updates. You'll need to use an Ethernet cable to connect your PC to the X130 port on the D425 controller. You'll have to open an access cover to find this port, and then just remember that the other RJ45 ports will not work for this. So we'll switch now to our desktop and show you what this looks like from a website or from the web browser side. So you'll set your computer's IP address as instructed by the service department, and then open your web browser, and hopefully we'll see that in a minute here. Okay, so open the web browser, and in the address bar you'll type in the IP address of the controller, and that again you'll get that from the service department. So the Simotion D425 web page should appear. Then you'll want to go and select the Manage Config page from the menu, and you'll be prompted for a password. The service department will give you the password, so you'll just enter the username and password. And then you want to make sure that the D425 controller is in stop mode. You can do this a couple ways. You can just look at the D425 controller and see that the stop LED is solid orange. And then if it's not, you can go to the settings page. There's a menu icon for that. The settings page is in the web browser, and click the stop button, and you'll see the stop indicator turn orange. Then you want to go back to Managed Config page, and then look in the section titled Send New Update Data, and then click on the Browse icon button. You want to locate and select the zip file that we sent you, and typically it will be named d425.zip. Once the file has been selected, you can click the Send Update Data button, and we'll spare you the time on that and go back to the PowerPoint presentation. It takes about a minute for the program to download, and then you'll eventually see a screen in your web browser that says the SIEMENS successfully loaded. And if you don't see the screen, you should just cycle power to the D425 and try it again. So after you've successfully downloaded the upgrade, wait at least 3 minutes for the update to finish. And once that's done, it'll notify you, and then you can power off the machine using the main disconnect, and then leave the power off for about 60 seconds before, again, returning the power to the machine with the main disconnect. Wait for the SIEMENS D425 to power up, and the upgrade process should be complete. You can look at the LEDs on the face of the D425 and see that the ready and run LEDs are solid green. And in that case, if they're not, cycle the machine power again. Let's change subjects a little bit. We'll go to PLC memory resets. There have been a few occasions where I've asked customers to reset the memory on a PLC. So why would you want to do that? Well, the micro memory card has been replaced due to program updates, as we previously discussed. And another reason is to clear all the retentive memory bits, timers, counters, and to initialize work memory with start values, or the retentive data blocks in load memory. Or in other words, we just need you to reset the memory in an attempt to correct a fault. Now, when the memory reset is done, keep in mind that the program is not erased from the micro memory card, so it'll still be there for you, but it is cleared from the CPU memory. The network addresses, so MPI, Profibus, Profinet, are not erased, so the PLC will still communicate with all your networked I/O, HMI, and other devices. And then also the diagnostic buffer in the CPU is not reset, so if we need them, we can still recover the CPU diagnostic information. Now there's a couple methods of doing this. We'll first review the method specified by Siemens. And so for this method, you'll first start by taking the key switch on the PLC into the stop position, and then take the key and move it to the MRES position and hold it there until the stop LED lights up for a second time and then remains on. And this process takes about 3 seconds. Then you'll release the key switch and then again move the key into the MRES position within 3 seconds and hold it there until the stop LED flashes at about 2 hertz. You can then release the switch, and when the CPU has completed the memory reset, the stop LED will flash and then stop flashing and then remain lit. The CPU memory is reset, and then you can move the key to the run position and the program will load. Now there's another method that we've found for resetting the PLC, and this method may not do everything that the Siemens method accomplishes, so you'll not find it documented by Siemens. However, it is sufficient when you need to reset the memory for a new micro memory card. And we think this is a little bit easier process. So you'll remove the power to the PLC. You can use the main disconnect. Remove the micro memory card from the PLC slot. Power up the PLC, leaving the micro memory slot empty. And then wait for all the LED lights to turn off. And then for the stop LED to flash. And then finally remain lit. And you may note that the DC 5-volt LED will also remain on. Once this is accomplished, you'll remove power from the PLC and then reinsert the micro memory card into the PLC and power up the PLC and wait for the LED to light up, the stop LED to light up. Then you can move the switch from the run position to the stop position and then back up to the run position. And the program will load in your PLC and the run LED should light up. Now, I'd like to just make a mention here that it is possible to reformat a micro memory card, and this means that the contents of the micro memory card will be completely lost. So why would you want to reformat the micro memory card? I really have no idea. In fact, we really don't want you to do this. We just want you to be aware that this will erase everything, which means you will have to order a new micro memory card from us and wait for it to arrive. So the good news about all this is it's really hard to reformat a micro memory card. If you don't do it just right, it's not going to reformat. Another topic that we'd like to discuss with you is backing up part data to a computer. We've had many people ask us for help in storing their part data on a PC so that they have a backup. And I'll go through the steps for manually doing this with a computer. So again, like everything, we'll remove power from the HMI before you remove the SD memory card. Remember, it's always important to do that. And then use a USB adapter to connect your SD card to your PC. And then using Windows Explorer, copy all the PTRCP files to a storage location on your computer. And then before removing the memory card, be sure to use the Windows application that allows you to safely remove a USB device, and then you can return that memory card to your machine. Now, note that the files that you are backing up are located in the root directory of the memory card. These files contain the part data for all the parts that you have created and stored, and then also the machine data, which defines the parameters of your machine, and any other data that is unique to your machine type. For instance, thin presses have additional die data files on them. It'll be up to you to establish a logical method for keeping track of which data files belong to which machine. I suggest that you create directories or folders using the serial number of the machine to keep these all separated. And it's important that you don't copy machine data or switch machine data between different machines. The configuration parameters in those files are machine specific, and they contain such information as the home positions for the axes and limits on your axes. So let's talk a little bit about PLC diagnostics. And most of our customers are familiar with the diagnostic information and the tools that we display on the HMI. Our goal in creating these diagnostic screens was to provide you a way of getting information from the processors that most people are accustomed to getting by hooking up a PC and going online. So I just want to highlight a few features that you should be familiar with. From the main screen, and actually most of the screens, we display messages across the top of the screen. And they should help you determine the cause of machine problems. If you end up calling for help, please include the message code that appears in the square brackets at the beginning of each message. And this helps the service department and the engineering people assist you very quickly. There's also sequence and step numbers. So if your machine has problems and you call for help, please also report the sequence numbers that appear on the main screen. And the easiest thing to do is just take a photograph of the screen in its faulted state and email that to the service department. Now, while we're talking about information to service, it's very important to include the complete Burr tool machine serial number when calling for assistance, and that lets us know exactly what machine we're working with. Another screen that we've provided is a diagnostic screen, and this screen will display a history of the last messages displayed at the top of any of the screens on the machine. And this list can be helpful in diagnosing problems by displaying the recent events that occurred on the machine, events that were expected and events that were unexpected. Another screen that we provide is the input and output screens. And these screens are useful for determining the state of the input devices on the machine. The indicators next to the address and descriptions display whether the sensor actuator is on or off. The state of the outputs can be forced from the HMI, just as if you were online with a PC. And because you can force outputs into any state, you must understand that it is possible for you to damage the machine by moving an actuator into an interfering position. So for this reason, access to these screens is restricted by a password. We also have a VAT table screen. These screens allow you to view the current value of a memory address. If the service department needs you to check the value of a memory address or a variable, they will give you the address to enter into this screen so that you can report the value of it. And then, of course, we have manual screens, and these screens allow you to safely move actuators and axes on the machines. All machine interlocks are active to protect the machine from damage, unlike the output screens. I'd like to again go to talk about a new function, or a function that's new to us, about using a web server to view some diagnostic information. So Siemens has provided us access to PLC diagnostic information with their integrated web server. This feature is new to Burr Tool, and we are just introducing this, and we'll be implementing it very soon. So this is available to all PLCs that have an RJ45 port for Profinet communications. You'll find these on the Triumph or SD hairpin vendors, the fin presses, expanders, HPEs, and the small return vendors such as the MRB, RBCUs, and SRM. So going to the desktop, we'd like to just demonstrate a few of the features that we believe will be useful. And it's important to remember at this time that not all Ethernet controllers have the web server enabled. This is a Siemens function that's new to us, and we're still in the beginning stages of implementing this function. So at any rate, from Internet Explorer, you'll type the IP address of the PLC, and then you'll get the web server page. Then click Enter, and you'll be presented with the start page. Here you'll see the current status of the PLC. Now, hopefully it says OK and run, but the reason for you coming to a screen like this is probably because it doesn't say that. So we'll go look at the diagnostic buffer, and this will store up to the last 100 CPU events, such as CPU restarts, mode transitions, and power status. If the CPU memory has been reset, then at least the last 10 events should still be present here. A message will be here if a communications fault, I/O fault, or hardware fault has occurred. And if you click select a message, the lower portion of the screen will display detailed information about the fault. Now, this screen does not show any errors on the from the program created by Burr Tool. The message you see are only those related to the operating system on the CPU. So what's the value of the screen? If a particularly difficult problem occurs with the control hardware, Siemens may ask us for a copy of this diagnostic buffer. And you can save the contents of the buffer by clicking the Save icon in the upper right corner of the window. And then you can just save it to a file. There's also a tag status. We can go click on the tags, go to that window, and here you'll be able to look at the current value of a memory address, or what Siemens calls a tag. And we can demonstrate that with the PLC we're hooked up to. So we'll type in M0.0, which is a memory address, and its type is Boolean. So we'll enter that in the selection box. And then we'll also type in MW1, which is a memory word, and we'll look at it as a binary type. And then we'll click the Apply button just below that. And then we'll be able to see the status of those memory words. And if you hit the refresh button in the upper right-hand corner, we can see that the status changes. And it takes a little bit to refresh. So our bit went from false to true, and the bits in the memory word have changed. We can click it again just to see that. And then the other the other web pages that are available, we've not yet found the use for those. So those are just some things we wanted to introduce. I'd like to go back to our slide presentation. There's one other thing that we've recently come across, and it's actually a non-PLC topic, and it has to do with our circuit breakers. And there's a difference between the way Siemens marks the logic state on their contacts and the way Burr Tool draws circuits on the schematic. So we've made a change to kind of make everything correlate. So Siemens prints on the contacts the state of the contact when the breaker is tripped or in its off position. So the left picture shows the breaker is tripped. The meter is on the NC, or normally closed contacts, and shows that the circuit is closed. And the right picture shows the breaker in the on position. And the meter, still on the normally closed or NC contact, shows that the circuit is now open. So Burr Tool electrical schematics will now show the logic state of the breakers in the off state in order to match the logic state printed on the breaker contacts. And the schematic will also include a nearby note, as shown on this slide, explaining the contact state when the reset lever is in the on position. The idea is that when we're troubleshooting a circuit, the printed contact logic and terminal numbers will match the electrical prints and should be followed. All this, of course, can be tested with a multimeter as we demonstrated in the photographs. And just as a concluding remark on here, we just have share with you some Siemens website addresses. These are addresses for the U.S. and the international Siemens support website. The international site, you can change the language you wish to view it in. And there is a lot of information available on these screens.
Thank you, Eric. Thank you very much. We will now transition to our question and answer section of the presentation. For those of you who do have questions and have not yet submitted them, please do so now by typing in the question box. Now, the first question we have is, if you experience a complete power failure, do the encoders lose their position? And if so, how do you recalculate them?
All right. Well, it depends. And really it does depend on the machine. On the SD or Triumph hairpin benders, those are absolute encoders, and so they will maintain their position. On our other machines, like the expanders and the other ones, those are incremental encoders, and those will lose position when the memory's lost. So you'll need to use the home function, and your operator should be familiar with that home function, or maybe those people who you've authorized to do more configuration on your machine. So you just run the home sequence and let the machine home itself, and everything will be good. Now, in the case of any of the machines, including the SD and Triumph benders, if you end up having to disassemble the mechanism connected to the servo motor where the encoder is located, then you will need to resynchronize the encoder position with the physical position of the axis. And so that is typically sufficient to be done with just homing the machine again. If you run into trouble, then the service department is well capable of helping you through that and walking you through that process.
Okay, thank you very much. We don't have any other written questions submitted at this time. If there are further questions, please write them. Otherwise, I will review just some closing points. We at Burr Oak Tool are striving to improve on everything that we do. If there's any feedback that you have for us, whether it be a future webinar topic that you'd like to recommend, any feedback on machines that you have on your floor, recommendations with improvements that you see that you would like to have implemented, you can submit those to feedback.burroak.com. And that is something that we monitor on a regular basis and will respond to. So Eric, thank you very much for your presentation and preparation for this. Appreciate everyone. Oh, we have one more question that came up. Let me read that quickly. For Eric, is there anything that should be done to avoid accidental reformatting of the SD card?
Well, the best place for the SD card is in the machine, and so if you just put it in your PC to back up the part data and the machine data, and then restore it back to you, or return it back to your HMI, then you should be fine. And that's probably why a lot of people are asking for the ability to back up all those machine data files in case something does happen to that SD card. As far as the Siemens ones that are in the PLC, there really is no reason to put those cards in any other device other than the PLC. And they are actually a little bit different in size. I think Siemens did that on purpose to kind of discourage you from maybe using them in a camera or some other device. And So just if we, if you keep those cards where they belong, I think everything will be fine with them.
Thank you very much. Everyone who was on with us today, thanks for joining us. We hope that you have a wonderful rest of your day wherever you may be. And just once again, for any improvements, suggestions, we encourage you to submit to feedback.burroak.com. Thank you very much for joining us.